Hello everybody, and welcome to the PyData Sofia June meetup. Similarly to two of our previous meetups, we're doing this online. And as always, if you'd like to talk on one of our future meetups, please write me a message or write message to one of the other organizers, Yasen and Milen. Besides that, we'll stream everything on YouTube for this meetup. And if you'd like to check the talks from the past, from the April edition of PyData Sofia, you can check the channel that is streaming now. As always, if you have any suggestions for us how to run these meetups more efficiently online, or if you'd like to suggest an other improvement, just reach out. An important thing to note for this meetup. So last year on 18th of June was our first PyData Sofia meetup. So almost to the day, this is our anniversary meetup. We're off just by one day. So on that note, I would like to thank all speakers and meetup attendees that joined us for the past year, and I hope you'll be with us for the next years while we run PyData Sofia. So today we have two talks. First, Greta will talk about data wrangling and plotting in R. And after that, Guy will talk about analyzing public opinion with natural language processing. After both of the talks are done, we'll send the link to the meetup room where I invite you to join us, so we can continue the discussions about the talks that you heard, or about any other project or idea you might have. If you have any questions to the speakers during the talks, please either use the YouTube comment box that is, I believe, on the right-hand side of the screen, or the link in Slido. I share it in the YouTube comments. If you just go to sli.do, you can enter the code PyData, and you'll just be redirected to the question site again. One thing to note here, when you do ask some questions, please include any relevant context to your question. Like, instead of asking why is that, ask why would you use the method X for Y application, and so on. I'm saying this just because we had some context troubles with our last meetup, and I was unable to convey all the meaning you had when you ask your questions. So now, without further ado, our first speaker is Greta. She's a final year PhD student at the University of Glasgow. Her PhD focuses on testing theoretical frameworks of autism, utilizing behavioral and EEG methodologies. The majority of Greta's time is spent designing and programming experiments in MATLAB and Python, and then analyzing the data using R and MATLAB. The title of her talk is R, from the ease of data wrangling through the beauty of plots and the joy of ShinyApps. Just to mention something, this is the first time we have an R talk on PyData, so I'm very happy to now hand over to Greta, where she can start her presentation.
Hi, I'm kind of hoping that my slides can show. Not sure that they can, which is a bit unfortunate.
It'll be fine.
Oh, 1 second. The joy of Firefox. We do seem to be having some problems on my side.
If you want, you can try leaving the conversation and rejoining. Maybe it would help.
Sure.
Okay, we'll start in just a minute. It wouldn't be a PyData meetup if we don't have any technical problems. So let's hope everything could be fine soon. Hello again. We can't hear you at the moment. Hi.
Hi.
Welcome back.
Let's try again.
Let's try again. Okay, we can see your screen now.
Yay!
Everything is working.
Isn't that great? As I said in the beginning, the joy of art.
Yeah, the meetup is yours.
Great, thanks. Well, hi everyone. Sorry about that. There's always going to be technical issues, as we all know. We did try everything beforehand, but oh well. So as Georgi said, I am a PhD student at the University of Glasgow. I'm a final year, and I have spent the last 3 years of my life doing analyses in R and MATLAB. Unfortunately, I do prefer R, and programming a lot of things either in Python or in MATLAB or whatever other derivation there comes of. But specifically about R, I have used R for the past 4 years, which is when we got introduced to it. I did SPSS before that for my undergraduate, and then my master's here, we were told, you're going to do advanced statistics now in R. Here's a 3-day bootcamp, and this is how I got introduced to it. And even though everybody hated it from the beginning, then we decided we can't live without it, and I haven't stopped using it since. And I think it's a great tool for academics and for statisticians, because in the end it is a statistical tool. And I'm hoping to convert at least one person from today to at least consider R as an option. There are at least 5% of people who use Python before that then go to R afterwards. There's research on it, I've checked. So R, from the ease of data wrangling through the beauty of plots to the joy of ShinyApps. I'm gonna go quickly and cover all of these 3 topics, and hopefully I'll be able to sell R to you. So R was developed by statisticians and academics for statistician academics, and in this way, it is in a statistical software. So it's best at dealing with data, manipulating data, doing statistical analysis for it, graphically presenting it, and modeling. So this is why it's so good for academics and researchers and students, for that matter, who don't have any computational or not computation, computer science education, because they don't tend to know specifically how to program. So when you tell a student specifically that they have to now write their own code in order to analyze their own data, it's much easier to try and introduce something that has a statistical logic in the way that the code is written. There's something that is a completely programming and developing tool, like things like Python and JavaScript, for example. So R has been gaining a lot of traction in the past couple of years. If we just look at Stack Overflow, which is the beautiful graph on the side here, we can see that R, if we exclude Python, JavaScript, Java, C#, and PHP, which are players that R shouldn't even be in the same playing field with, we can see that R has been gaining quite a bit of traction in terms of the number of questions and views per month, and this is only up until 2018. However, if you look at the, I'm going to go with TOP index for most popular programming language, you can see that R is in number 9 this June, where it was number 22 in June last year. And the popularity index here is calculated just based on how many times it was searched on any of the search engines. And it is an extremely useful language because there's so many people or so many academics using it that there are so many people asking and answering questions. So it's a massive community. And making it easy to read and follow syntax is what makes it so appealing to academia. So what is one of the best things about R? One of the best things is the amount of packages and functions and anything that you might need to do. Somebody has already done it and put it in a package, or that is already on CRAN, which is a package repository. Or if they haven't put it on CRAN, they've written it up, put it in a package, and put it in GitHub, and where you can go and download it. Or even if that's not there, there's a statistician down the hall or like the office next to you, which I have one of those in my department, that I can go and knock on the doors and ask them, I'm trying to do this, and they'll send me a text file with a bunch of R functions that I can use in my analysis. They're extremely easy to install. They're extremely easy to use. There is no pip, thank God, because I can't deal with pip. However, it doesn't matter where your package comes from. You're just installing it as anything else. You're installing a package and then you're loading it using library. And it's the same kind of code, regardless of whether it's you're downloading it from a CRAN or from GitHub. I'm going to be talking specifically about the Tidyverse package, which was created by Hadley Wickham, and it introduces the Tidy universe. It's a compilation package that combines a lot of packages that are there to help you manipulate data and make it into the format that you might need it afterwards to either create plots with it or do statistical analysis on it. Additionally, the package contains ggplot2, which is the package that creates wonderful plots, which are the biggest selling point of R when you try selling it to undergraduate students. So, how I'm going to introduce this to you, I decided that we can look at some of the Scottish Government data that they have at statistics.gov.scot. They have a vast majority of data files and open source documents that you can use and then analyze. It's data that is collected throughout the years, throughout different councils, different NHS health boards. So there's a lot of data there that you can do a lot of fun things with. So here I've decided to have a look at are Scottish people, is the mental health and the mental well-being of Scottish people changing throughout the years, and is that related to how far they live from a park or from the sea, so from a green or a blue space. So I've downloaded two datasets from the Scottish Government website that look exactly into that. Additionally, I have wrangled a dataset that is called the Geo area here, that just contains the feature codes which is the code of each of the councils or the NHS boards, etc. In this way, it will be able to give it not only a number, but also a name. So if you look at the data for the green and blue space proximity, we can see that it is a very nice table. You have all of the information and it is extremely complete. You have 95% upper and lower limits. You also have the percentage that is in the middle. You have how far the people live. So whether they live 5 minutes, 6 to 10 minutes, and 11 minutes or more away from their nearest green or blue space. You have it separated by age, by gender, type of tenure, household type, etc. However, this type of data set becomes a little bit too clunky to work with, although it has a lot of information. Just for the purposes of today, I'm going to reduce it down quite a bit. And I'm going to do that by wrangling it using tidyverse. So it is a nice looking data set. However, it has a lot of unnecessary information. And for those of you that know how to use pipes, and I'm sure most of you do, the idea is that you don't create a number of objects in your environment that start up wasting space and make, well, in R's case, make R slightly slower in doing its computations. So the good thing about the tidyverse functions and the package as it is that all of the functions are there as in verbs inside of sentences. And then when you add in the pipe afterwards, you can read a whole chunk of code that analyzes your data in a way as of one very long paragraph. So if we look at the data set with the proximity to green and blue spaces, you can see here that this is quite a lot of code, but in reality, it gives us one extremely neat table at the end. And it's very easy to read in terms of what exactly I have done to this data set. So I have decided to pick the data set, which is green_blue, which is what I named it. And then I'm filtering in. So I'm keeping only the relevant rows that I care about. So I don't want to look at the data for males and females. I don't want to know what are the SIMD quantiles. I don't want to know what the urban-rural classification is. However, I do want to look at it based on age. Therefore, I don't want the compiled all. And I don't want to look at the 95 percentiles, and I just want to look at the percentage. And I also want to know how far exactly they lived from that green or blue space. So answers like I don't know are not really useful here. So in all of this, I have already reduced my data set quite a bit. I'm adding in our geo area data file that has the names of all of the councils by the variable that is common to both of the tables, and then I'm selecting only the variables that I really need, and then I am renaming the variable code value to something more meaningful, like % of the population that lives X number of minutes away from their nearest green blue space. So just by reading this, it makes it extremely easy to follow exactly the train of thought. And when we teach students in psychology, specifically on how to wrangle the data, how to make their data into a format that they can then use, it's easy to ask them to think about how they would do it step by step and writing down all of these steps, because then they can just follow them, because it's exactly the same language as you would use when you're trying to explain what you're going to do step by step. So from all of this, you end up with a very nice and neat presentation of a data table that gives us a lot less information. Of course, this is only the first three rows, but you can see that in South Ayrshire in 2014, there were 68% of 65-year-olds that lived 5 minutes walk or less away from a green or a blue space, which is great for all of those 65-year-old people. So data wrangling becomes extremely straightforward because more or less follows the same type of pattern, and it's very easy to get into. Once you get used to the name of the functions and how each function works, you can write basically paragraphs and paragraphs of code where you're wrangling your data into a format that you want to look at. And even if you look at the data that I've wrangled for the well-being of the Scottish population, we can see that it's exactly the same. I'm choosing the data set, I'm filtering the relevant information, I'm joining it with the names of the council areas, etc., etc. So we have all of this data. Now what do we do? Well, first of all, we want to plot it. And as I said, ggplot is a part of the tidyverse package, and it is an exciting addition to R because it makes wonderful plots. And as I said, this is the way that we try to sell R to students. Specifically, if you have done SPSS like I did in my undergraduate, you know that plots that are produced by SPSS are not the most beautiful plots in the world. So ggplot, along with all the wrangling that I just did, again follows this type of layering pattern where you add in on top of each other. So ggplot is always the first function, which starts off with, this is the type of data that I want to look at. In this case, I have said that I also want to look at specifically at the Glasgow City Council, the City of Edinburgh Council, and then the Highlands. And I'm specifying what is my X, what is my Y, and then everything from then onwards is just specifying what goes on top of the grid of the plot. So I'm saying that I want to plot my data. I want it to be colored based on how far people live. I want to separate it by age. So I want to have different small graphs for age or for and for where they lived. I want to create my themes appropriately. So I want to have a black and white theme, so I don't have to go and change the background and change the all of the labels specifically, but I can have something that is already there and then just add on top of it in specifying that I want my axis to be blue and my legend position to be on the top. And this is the same kind of pattern that you would do absolutely always when you're trying to make a plot. You're picking what you're plotting, you're saying what type of plot you want, and then everything else is just making it prettier and prettier. So how does this kind of plot look like? So this is the plot that the code that I just showed you, and this is the plot that I created for well-being. What we can see from here is that indeed it seems that there is some sort of difference between where people live and how old they are, and how far away they live from a green or blue space. However, you can also see that there doesn't seem to be much difference in general. A lot of people live very close to a green or blue space in comparison to fewer people that live further away. However, this is not the case for Glasgow. Potentially, this is because in Glasgow, it's a much more spread out city. Therefore, you have people that live further away from their nearest park or a river, whereas at the city of Edinburgh, which is a much smaller location, it's easier to live to something that is 5 minutes or less closer to you. On the other hand, we have the Highlands, which well, basically the Highlands is just a lot of green and a lot of blue. So it's very easy there to have above 80% of the population living near a green or blue place that's 5 minutes away. And if you look specifically at the well-being, we can see that the well-being does tend to differ based on where the people live. Specifically, Glasgow people seem to be a lot less have a lot less positive scores in terms of mental well-being, whereas in the Highlands, the variation does change depending on the age of the individuals. However, the general pattern does seem to be that with the progression of the years, regardless of age, you do tend to see some sort of decline in the mental well-being scores that people are giving. So we have some sort of an idea of how the data looks like. We have some sort of an idea of what kind of trend there is. So how do we progress from here? Well, as I said, R is a statistical software. It is there to help statisticians and academics do statistical analysis, which means that the outputs from statistical formulas and statistical analyses are going to be easily read. Yeah, easily read. So let's say we want to know whether Scottish people's mental well-being reduces throughout the years, and we want to know whether that change is significant, and we want to know whether living closer to the sea or not is related. Specifically, we want to know whether it's 5 minutes or less, because all the other ones are going to be additive to those 5 minutes or less. So if we remove the overall Scotland council or country in this case from the whole data set, and then we add in the data set from green and blue using an inner join function, which is similar to what we had in the addition of the names of the councils, we can then have a look at a simple linear regression of how the year and the percentage of the population that lived 5 minutes or less away from a green or blue space affected the well-being score of the individuals in Scotland. So if we have a look at the output is extremely straightforward. It tells us the spread of the residuals. It tells us the coefficients, which is something that you always want to know. You have your intercept, you have your beta values, you have your interactions here, and then you have all of your R squares and then adjusted R squares, etc. And you also have, of course, a p-value, which is how significant is your R squared. But what's more important here is to see that based on the data that we were looking at, we can tell that yes, throughout the years, individuals do tend to reduce the amount of happiness or mental well-being that they possess, or at least what they report. Something else that we noticed from the graphs before, from these graphs, is that there seems to be quite a bit of variation in terms of the well-being score based on where people live. And specifically, if you look at middle-aged adults, which are from 35 to 64 years of age, we can see that although in the cities there seems to be some sort of a reduction in terms of their mental well-being score, there seems to be an increase in the highlands, whereas all the youngsters and the 65 years and over individuals do tend to show a similar pattern. So let's think about how we can look at that. We've plotted some plots, but if you have to look at absolutely every area and we have to create a plot for absolutely every area, that will become extremely cumbersome. And then if you have to do a statistical analysis on it, at this point, it might be underpowered because we wouldn't have that much data to work with. So let's make everything on top of a map so that we can visualize it. Sometimes visualizations are a lot more important in order to extrapolate what type of pattern might be going on. So there's a different package here that I'm going to use, which is similar to ggplot. However, instead of creating two-dimensional plots, it can create, well, it's also a two-dimensional plot, but it creates maps instead of histograms or scatter plots, etc. So we can get the data from the Scottish government. They have created a shapefile for the shape of Scotland and where each council is, and then we can join in our well-being data with it. As I said, we want to know specifically about the 35-year-olds to 64 years old. This is because we did see some sort of variation in them in the graph that we were looking at. And that's why we're going to only focus on them. So you can see that the syntax is pretty similar to ggplot. If I'm not mistaken, it was inspired by it. It's again the using the layering system. So in the first layer, you have what is the shape, what is my data, Scott well-being, which is what we just created. And then you're basically saying what exactly do you want to plot? Well, I want to fill in all of the councils with different areas based on the score that they got. I want to pick a specific style similar to the teams in ggplot, and then I want to have some sort of variation in terms of the width of the legend. And then the last line is what allows me to further make this map a lot more interesting. Is I'm saying that I want to look at the year very differently in terms of I want to look at it separately, but I also want to look at it in terms of an animation. I don't want to have 5 different plots, one next to another. I want to see how it looks throughout time. And this is what tmap animation, which is an additional function with the tmap package that helps. And we can, if we look at the data, which is nicely plotted here with this nice GIF image, we can see that there definitely is something that 35 to 64-year-olds do tend to feel a lot happier throughout the years, especially if they start living in the Highlands or if they have been forever living in Highlands. Potentially, they've always thought that life was better in the city, and then they realized that their life is much better in the Highlands around all of the green and the fresh air. So this is how you would analyze a type of data set. You can see that it's extremely straightforward. It is very easy to be able to follow more or less the same type of steps until you reach your end result. Of course, you can do a lot more with R. You can do a lot of modeling, a lot of programming, a lot of you can build something from the ground up if you're really keen to, but for the majority of the time, for statistical analysis, from data manipulation, you wouldn't need to do that. So this is what makes packages like Tidyverse and specifically R so good at it, because it's easy to teach academics that don't have any computer science education. And now I want to show off a different functionality of R, which is a creation of ShinyApps, which is the ability to create an app without knowing how to create applications in general. I have worked on several apps, and I have never developed an app, for example, in Python or in anything else. It will probably take me a lot longer to learn how to do that, even though I do use MATLAB and Python, etc., on almost a regular basis. So here I'm going to show you exactly how it's done. It's all in one script or two, depending on the type of philosophy. You have some people do separate it, and sometimes if you have a very long app or a very big app, you do want to separate it because it becomes too long of a script. But for most occasions, you can do it either way. So let's have a look at a simple Shiny app, which was developed by RStudio. So this is the simple Shiny app. It is one file which has the user interface, which is one big function, which basically tells exactly what you see, what you would expect from a user interface part of an app. It tells us that we have a title panel, we have a sidebar panel. It tells us what we have in that sidebar panel. So we have radio buttons, and then we have the slider input, and then we have a main panel with all the 3 tabs. Additionally, after we've done setting and telling R exactly what we want our app to look like, we can then go on and create the discovery part of the app, which is describing exactly what happens basically at the backside of the application. So here we're saying that this part of the app is going to be reactive. So every time something switches in here, so the input from this, which comes from the radio buttons, because this is how it was named, this is going to create some sort of function, and then using the input from the number of observations from the slider, we're going to create a distribution. So that distribution is then going to be used into the output of the plot, which will create the plot on its own. It will also create a title, and it will also create the summary at the end, and then it will create the output table, which is at the third side. So if we have a look at how this looks like, let's say I want to create a exponential distribution, and I want to have 700 observations. You can see that it highlights exactly what I'm changing and what is being produced. If you go to summary, you'll be able to see that summary gets highlighted. So it's going to tell me exactly what the summary of that data set is, and then it will show me exactly the table. So this is an extremely straightforward way to make apps, and you can make a large amount of apps on different variety of maps. You can make almost anything into an app if you're keen to do so. So here I have suggested a couple of variations. So you can go from very simple apps. For example, the Scottish National Records and the Scottish government have an app where you can pick what your name is, and you can check how popular that name has been in Scotland for the past several decades. So for example, if I look for my own name and for a Carol and a Carol with a C, then we can see that after a while we can see that there are at least 6 little girls that have been named Greta in 2019, where there haven't been any Carols, regardless which Carol with a C or Carol with a K, and whether it was male or female. So yay for me, or yay for my name. I'm being popular. Additionally, you can have things like an effect size calculator, which I'm not going to show off now, but you basically can just plug in whatever you want, and it's just something similar to this one. And you can have something a lot more complex. So for example, you can have a map of the UKs with data from Police UK, where it will be able to show you exactly the distribution of crime. So let's say we want to look at crime in Cambridge. And then it will be able to show us exactly the distribution of crime in Cambridge and the type of crime. So Cambridge has a lot of antisocial behavioural incidents, quite a bit of bicycle thefts, not that much burglary. If we look at Leeds, for example, then we'll be able to see that there's a lot more of violent crime in Leeds, and shoplifting and antisocial behaviour. So you can scroll around all of the data that there is available, and you can pick your own city and see what happens. Alternatively, you can go completely out and do whatever the Scottish government does, is to create massive dashboards that they're used to present the Scottish government data and statistics. So in this case, I'm going to show you the Scottish Energy dashboard, which shows off how Scottish Energy is being used. Of course, it's going to take a while because it's an extremely heavy app, because it has a lot of things on it, and it can show quite a lot of things on it. But it tells us about Scottish Energy statistics. As I said, you can look at, for example, COVID-19. You can see the daily demand for electricity. You can see what it's like last week of this March in comparison to last week of March. So this is the first 3 weeks of March, whereas this is the last week of March and to the second week of June. So you can see that the beginning of March, there was a lot more electricity used in comparison to after the lockdown happened, for example. So I hope that I managed to convince you that R is fun. It's easy to use, specifically if you're working with data manipulation and with data visualization and analysis, and in statistics specifically, because it makes things a lot easier just to write and to understand, and then to teach other people to do it, which is a lot of the stuff that we do in academia. However, if you need a little bit more convincing, there is the joy of RStudio, which is the IDE for R. It allows you to create wonderful markdown files, which is basically reports which are easy to create, and they are reproducible, and you can include all of your code in it, and then you only need to do is rerun the markdown once you collect more data, for example, and then you can have all of the information that you need. I have included R markdown file in the GitHub connected to this presentation. But it basically works similar to Jupyter notebooks, which I know are a favorite around people who work with Python. It also has an integration with ShinyApps, so you can create a Shiny app directly from R Markdown. It will be able to present it and create an HTML file for it, and you can use it and you can share it with other people. It's integrated with Git and GitHub, so you can work on it and automatically commit and push information into your own GitHub, into your own repositories. One of the good things that is great for teaching is the R bookdown, which is something that we had to learn how to use recently because we had to teach introduction to simple data analysis, which basically creates this type of format where it's basically a bookdown, where you can see all of the information, you can see all of the code, and you can attach fun little highlights for information that you want to know. You can have to show and hide the solution, etc. So this is a great tool for teaching if you ever want to teach anything. And of course, you can create presentations with it. This presentation was, for example, created with R, and you can create R projects where it's basically a container for all of the files that are related. So this was me. I hope that I have somehow managed to convince you that R is great. I think that R is great, and I have not stopped using it since the first time I learned it. Do I use other things in comparison to just R? Yes, I do. I do use a lot of Python because Python, of course, is a development language. It's used we use it for developing experimental paradigms that we test participants on. I use MATLAB for the same reason, or for analyzing additional data. I would probably never use Python, for example, for statistical analysis, however, because I find it a lot harder to use Python for that rather than to use R. And if you do want to know about all of the data and materials that are related to this presentation, I have included them in a little GitHub repository, which has a bunch of other teaching materials about R as well. And that's me. There's a slide with all the package references, of course. But yeah, that's me. I hope this was interesting to some of you, and I'm more than happy to answer questions if you're keen. So let me know.
Okay, thank you for your talk. It was very interesting to me, especially because I'm trying to convince myself to use R at some point of time, but yeah, sometime soon.
Well,
so I'll
please
encourage.
If you want to know, I'll be glad to help.
So I'll encourage everyone to ask their questions now, so I can read them back to Greta. We have 3 questions currently in the chat and in Slido, so I'll start from the beginning. So the first question is there any versioning of R? Is there any compatibility issues with version and packages, and how often R is updated, if ever?
So R specifically is updated every couple of months, along with RStudio, for example, is updated a lot less, but R is updated quite often. And there does seem to be some issues with package compatibility. Specifically, you can run things with the same package, and I have run things with the same package from 2 different versions of R and 2 different versions of the package, and sometimes you do get different results. However, every time you do load a package, it does tell you exactly for what version of R that package was created. And when packages are created, they usually require a specific version of other dependencies that they need to use. But I have seen that it can be a big issue. For example, there was a recent update in one of the packages that I was using, and then it suddenly started creating additional things out of the code that I was making that I couldn't figure out how to get rid of and why they were there. So there is some issues with versioning, but you can specify exactly the type of version that you want for the package, and you can use different types of versions of R in order to run whatever code you want, and you can make that explicit if you want to share the code, for example. Hope that answers that question in a lengthy way.
Thank you. The next question is, can you share the code snippets and presentation? Which I believe the answer is yes. You shared them in the last slide. And yes.
There is also an R Markdown file which has a couple of more code chunks with it, and it has all of the data that you need. So if you go to the GitHub, it will update to the final version at the end of the meetup.
Yeah, afterwards I'll share the link on the Facebook and Meetup pages, so everyone who is not currently here or didn't see the slide will get access to it. The next question is, I've heard R had a recent major release. Can you please talk briefly through the major changes?
Yes, R did have a major release. However, from a programming perspective, in terms of using it to analyze data, I don't really see the changes specifically. Some of the changes are a lot more visible if you use R in a more of a developmental type of way. So if you're developing things, you're more likely to see it. However, I don't see much difference between for day to day. I don't see much difference between the versions, which might mean that the differences are good enough so that I don't notice them in terms of they don't impact the type the way that I do my work. So I don't spend enough time to see how R changes from version to version, but it can have drastic changes. So I think that one of the previous releases, there was a change in the way that some of the output was presented when you run specific functions, which was a great improvement. I can't tell you exactly what it was now, because at this point I have decided I'm just going to accept that this is getting better, and I'm going to be happy with, rather than wondering why and why didn't before. But the majority of the changes are small enough that they're just outside of my specific fields of the way I use R. Sorry.
Okay, thank you. The next question is, why do you have to reload the ShinyApps you displayed?
Oh, so for the ShinyApps, they do tend to kind of expire in a way, mostly if you stop using them. So while you're using them, so I continuously click here and then I try to go around, it will not expire. But if it's idle for a long period of time, it just decides to stop supporting it so that it doesn't continue using information. I also forgot that you can't continue seeing my screen. I was just playing with the apps to show what I meant.
Okay, and the last question is, how long did it take to feel competent with R? How steep was the learning curve from using SPSS?
From using SPSS, considering that the way I used SPSS was the click and point method rather than the actual syntax, especially for the first couple of years up until the last year where I had to use the syntax for a couple of times. It is a pretty steep learning curve in terms of, I think this is what we teach all of our students. If you have no computer science education behind you, no programming background at all, it is a very steep learning curve. However, it is a steep learning curve and then it's a plateau in that kind of way. So I was extremely motivated because I had to be, and I had 3 days, literally the 3 days boot camp that we were given to learn how to use R. And it was great because I was in the same university for my undergrad and a master's. So that's exactly when they decided that they're switching completely to R. So they decided we need to be able to teach these students how to use R before we ask them to do statistics with it. And in 3 days with 8 hours every day, you can learn how to do the things that I showed today. However, afterwards, it does take a little bit of more time to get used to it. However, this comes on the back that I have had 4 years of some sort of stats education, which comes with my psychology degree. So for our undergraduate students that start with no statistical knowledge and no programming knowledge, it is a lot steeper for them. But we see that after the first year, and after, especially at the middle of their second year of undergraduate, which they have our classes every week, they become much better at it, to the point where in third year and in fourth year they're learning things how to do in R that I had to learn in my masters, and they're already better than us by the end of their fourth year. So steep, but plateaus after.
Okay, we have 3 more questions.
Okay.
So that was not the last one.
Okay.
The next one is, have you tried using Julia?
No, I haven't, but I have heard it is becoming extremely popular, especially in the past couple of years. There have been a couple of people that have tried to recommend it to me, but I think that it was always at a time where I was way too invested in R or Python at that point. But I would love to talk more about Julia, because I've heard very good things about it.
Okay. The next question is, tables are a relatively new data structure in R that basically replaced the data frame. Does old code that use data frame still function then?
Yes, the old data frames do function. In fact, there is a big debate in the data.frame functionality that creates the old data frames, that sometimes they are a lot faster in comparison to tables, and that does vary depending on the type of function that you're using. I have seen some simulations that show that data frames for specific functions are much better, especially in terms of how much data they can hold and how much statistical analysis you can do with them. So they're definitely still functioning. However, they're not integrated in a lot of the packages. So for example, if I do something if I create a data set and I create it within a data frame instead of a table, I might have some issues down the line trying to analyze it with packages like tidyverse that specifically use tables, not for all of the functions, but for some of them, tidyverse specifically relies on it being a table. So it depends on what kind of functionality the package does have. But for a lot of analyses, I have noticed that it doesn't really matter, because it just extrapolates the type of data. It's mostly for the data manipulation bits that I have seen it having issues. But it's still functional and still there, and still they're very big proponents for it.
Okay, and now finally the last question, I promise, is can you compare Shiny to, I believe this is pronounced Bokeh and Plotly? Which is the best for big data?
Oh, unfortunately, I can't. I have not used either Plotly or whatever the other one was. I'm sorry, I could not remember the name of it. But if you can tell me more about it, I'll be keen to learn.
Okay, then perhaps this is something that you can discuss after the next talk, when the discussion phase of the meetup is on. So for now, I'd like to thank Greta for your wonderful talk, and we'll continue with our next talk on PyData.
Thank you. I look forward to the chat afterwards.
Okay, Guy, can you try sharing your screen?
Yes.
Okay, we can see your screen now. So our next speaker is Guy, who is a second-year PhD student in the Natural Language Processing group at the University of Cambridge. His research looks into principled ways of storing information in knowledge graphs and then using this as a basis of interpretable common sense reasoning systems. The title of his talk is Which Laws Should Go? Helping Social Scientists Analyze Public Opinion with Natural Language Processing.
Great, thanks very much, Georgi. So yeah, as Georgi said, I'm a PhD student at the University of Cambridge. I'm not talking today about anything particularly to do with my research. Today, instead, I'm talking about how we can analyze real-world data sets to help out social scientists. In particular, I'm thinking about one data set, which comes from the UK government, who ran this survey in the summer of 2010, Your Ideas for Your Freedom. So they were asking the public for their feedback on laws that existed, whether they thought that some of the laws should change, or whether they thought some should just be completely abolished. This resulted in one piece of legislation in 2012, the Protection of Freedoms Act, but not much other sort of public analysis has been done of this, and it's not the governmental analysis isn't clear. So myself and some social scientists I'm working with are interested in seeing what's in this data set. So what does this data set actually contain? What does it look like? This is an example, a real example of something that was submitted. So the title of the idea is that the carbon levy and green review is urgently required. They sort of expand on this by saying that the government should urgently review these unnecessary levies and taxes on so-called carbon producers, and they go on to justify their idea. So whatever the agreement or disagreement on global warming or green issues, we need to review the costs and impacts of these hastily applied levies. There are also some tags that were made by the community on this website. So carbon, climate change legislation, and tax. In total, there are 5,000 or so of these responses, and 800 of these have been manually tagged with a few different categories. So with this, we've got some questions we want to answer. We want to think about how the public views the law. We want to sort of see if we can mine the data set, get some insights out of it, and use that to guide manual sort of evaluation, manually looking into what the data set contains to see how the public view the law. We also want to look at if there's any correlation between what was on the news and what was submitted to the survey. So if there was a thing about global warming in the news, was there a spike in environmental responses recorded sort of in the next few days after that? And we also want to analyze that bit of legislation that I mentioned at the beginning. Does that actually address what the public were talking about, or does it not? And the fourth, which is where my work comes in, is can we use NLP to help it with this? So on a basic level, it's useful to have some kind of computational processing of this data. Because as I'm sure many of you are familiar with, it was very noisy. It was full of random HTML fragments. Cleaning that out by hand would have taken a very long time, so doing it automatically was very useful. But on a sort of pragmatic level as well, there's way too much data to hand tag this. Tagging 800 of these examples took long enough, and doing 5,000 would be prohibitively sort of expensive. Let alone sort of doing that for all of the news articles. There are tens of thousands of news articles that I scraped in the sort of 3 or 4 months that this survey ran for. So it's not possible at all to do this kind of analysis without natural language processing. So these are the tags, some of the tags that the manual coders, the manual taggers came up with. So there's a topic, which is, for this one, environment. So this is the main thing that the response is talking about. There's the sophistication. So that's whether the argument that is being made is sophisticated or not. So that's one of 4 levels. So it's very low, low, medium, or high. There's also a couple of binary tags. So whether or not a law is mentioned. So this response doesn't mention any laws by name. And there's also no vested interest here. So the person responding to this survey doesn't really have a very vested interest that they've made explicit on the levies and taxes. If they'd said that they maybe run some kind of, maybe they're an owner of a coal factory, a power plant or something, then they'd have a vested interest if they've mentioned that. I'm going to talk today about how we can automatically code for the first 2. So what kind of questions does that let us answer? So for topic, that helps us with the middle 2 questions. If we can automatically classify the topic of those news articles and also of all of the responses, then we can easily look for correlation between the 2. And then we can also use sort of that global high-level view of the data set without having to sort of go through all 5,000 to see if the legislation addressed the sort of main few topics that were brought up. So let's dive in. For the topics, I'm going to look at 3 approaches. So unsupervised approaches, semi-supervised approaches, and rule-based approaches. Unsupervised, I'm going to look at LDA, and then we're going to extend that in a semi-supervised way. This doesn't work all of the time, so we're going to then look at some rule-based systems to fill in the gaps. What is LDA? So LDA, as I'm sure many of you have heard of this, it's a common sort of unsupervised topic model that can pull out topics from a set of documents. So to train it, you just have a bunch of unlabeled documents, put it through LDA, and it will output a list of topics. You get to decide how many topics you want. So here there are n. And these topics aren't labeled. So we don't get a name or anything for these topics. We just get a list of words. So The first one, school, education, teacher, children. We can kind of guess that that's about children, education, even though we're not explicitly told. The second one, something to do with speeding. The third one is something to do with government. The fourth one doesn't mean anything. It's incoherent. That's one of the problems with LDA, is that the topics that are spat out, you have no guarantee that it actually means anything to humans. The model might have picked out some kind of correlation, but it has no means to sort of check whether that is actually meaningful. This topic is useless. If we label the document as this topic N, we wouldn't learn anything. So now that once we've trained a model, we can feed it new documents to infer what the distribution of topics is for a single document. So for this document, the speed limit should be increased to 80 mph. We use that list of topics that we learned before to get a probability distribution over those same topics. And we can see here that the one with the highest probability is topic 2, which was our speeding topic. And note that this is a probability distribution, so it all adds to 1. I'm going to briefly run through, without going into any maths, how LDA works. It's a lot more complicated than I have sort of made clear here, but that's not important, and I'm not even clear on how a lot of that works. But it's important for when we're extending it in the semi-supervised approach. The whole idea behind LDA is that we say that documents are generated by topics. So any of those documents at the bottom are a combination of one or more of those topics in the middle, and those topics in the middle, in turn, are defined, like we said before, by some list of words. So I've just I've put lines there just for the first 2 topics to what words sort of are in that topic, and this is just the initialization, so it's completely random. Both the topic word association and the document topic associations are completely random. And in the course of training, what we want to do is 2 things. We want to get a set of topics that maximally describes the documents. So we want, if we generated from the topics, we wanted to generate as much as possible of each of the different documents from those topics. And for that, we need to have good definitions of the topic. So the words associated with the topics need to actually correspond to something in the data. So we optimize these 2 things separately, and we do it iteratively. So the first thing we do is change the topic word distributions. So here the model's just decided, based on the data, to change which word corresponds to which topic. Now that we've done that, we can reevaluate which topics most generate each of the documents. So now, for example, topic 1 has changed from, or rather, let's talk about it in a document-centric way. So that first document on the left there used to be generated by topics 1 and 2. Now it's generated by topic 3. Now the model thinks that the words within topic 3 most accurately and most fully, I should say, cover the contents of that first document. Reiterate a few times until we're finished. So this is our finished setup. We have topic 1 corresponds to education. We can see that the topic, the word lists is teacher and children, and the second topic is speed and mph. And from that, we can see that that first document is sort of most fully described by our education topic. And the second 2 are described by those other 2 topics, that third one including the speeding one. So there are some pros and cons to this. A nice pro is that we can obtain multiple topics per document. So if you think back to that first example we gave, this is kind of mostly around the environment, but it's also about tax. So it's ideal if we can say, it corresponds to both. And even though we have a probability distribution, if we can assign as close to sort of 50-50, and then the rest of the topics, 0 probability, that's ideal. But the sort of downfall with this approach is that we have all of this labeled data and we're just not using it. It seems like a bit of a waste to have gone through all of that effort of labeling the data to then just chuck a unsupervised model at it. There's also the problem that some of the topics that we're interested in from the data, having sort of looked through it by hand, looked through those 800, are too similar to automatically pull apart. So you can imagine that driving, speeding, and vehicles have quite a lot of overlap in words. So probably a lot of them are talking about cars or roads, but driving is sort of distinguished by things like driver, speeding by speed camera or miles an hour, and vehicles by car, van, whatever. And it's just not able to pull that apart. So how can we solve that? What if we gave the model a hint for what words belong to what topic? And we can. So this is work by Jogalamundi and colleagues called seeded LDA. And it lets us give our own list of words per topic. So 2 questions: how? And how do we make those lists? It's a bit of a pain to make those lists by hand for all of our 50 topics. And we have all of this pre-labeled data. So, ideally we can just magic these lists out of those and use them. So the answer to the second question is yes, we can. And the first one is seeded LDA, this approach. So this is why I walked through the training procedure for LDA, because seeded LDA amends this in 2 quite clever ways that let us define what we want each topic to be. So we can see a similar setup to previously. I've got rid of the other 2 topics just for clarity, but they still exist and you can still have as many topics as you want. But you can see that in addition here, we've got 2 clouds of words. And I should mention as well that these words, it's not necessarily just words that we're using. It can also be bigrams, so speed camera or miles per hour zone. Those words in bubbles are seed words. So for topic 1, we kind of think that exam and student probably relate to it. For topic 2, those 2 bigrams, we want our topic to sort of correspond loosely to those. Now, it's not necessarily the case that our topics will end up reflecting those seed words. The model can decide, if it has enough evidence, to just abandon them. But it's quite a strong bias to begin with. So as before, we start with our topics consisting of just a random assortment of words. So our topic that we want eventually to mean something to do with education has event and jewelry, but we also point it towards student as well. And the effect of this is that because of the bias of those seed words, the model is biased towards picking out other words that correspond to this topic. So for example, for topic 2, we pick out MPH and speed from our 2 seed bigrams, which is great. And it solves our problem with driving, speeding, and vehicles. So, driving is motorways, drivers, traffic, speeding is speed cameras, vehicles or buses or whatever. So that's super helpful. So that's the first way in which the training procedure is changed. So that's on the word topic level. It also amends the document topic level just by sort of biasing, so it encourages documents towards certain topics based on the terms that they have. So instead of having just that totally random sort of assignment of documents to topics, we can bias it towards, so if that first document on the left contains speed camera, we'll bias it towards topic 2. It's just another way of using the supervised information that we have. Okay, that's seeded LDA. That's cool, that works. And we can just feed it with whatever list we want, and it'll do its thing. How about making those lists automatically? Well, we have these 800 document topic pairs. And what we want to do is find the bigrams and unigrams and bigrams that are most discriminatory for that topic. So if a word is sort of only really likely to appear in responses that talk about speeding, then we want to identify those and use those as our seed list. So briefly how this works is that across all of the speeding documents, we collect a bag of words. So we chuck away the word order because we kind of imagined that that's not useful. Instead, we're sort of mostly interested in mostly nouns, sometimes verbs, that sort of end up being very discriminatory, and we don't need the word order for that. So for each topic, we end up with a single bag of words. And then we use information gain to find which word is most discriminatory for each class. So we do that across all of the different classes. So here, HC is just the entropy of the class, and H of C given W is the conditional entropy of the class given the word. So you can imagine that if the conditional entropy is a lot lower than the normal entropy, then the word gives us a lot of information because it reduces the entropy of that class. So the information gain is high. That's why on the right, we take the argmax across the information gain of those speeding, comma W. And we can do that. We can not just take the argmax, we can sort of do an arg sort and take the top 10. It's as simple as that. It does require some hand crafting though. So this is what was taken out of the taxation tagged examples. So you can see that that first term is not salient, possibly insane. It doesn't have anything to do with taxation, yet this technique is picked out as very salient for taxation. That's probably because it was only mentioned a couple of times in the data set. I did some thresholding, so very infrequent words and phrases are not included in this. But it's possible, if we think back to how the data originated, this is a public forum. So it's possible that someone went through and, thinks very poorly of ideas to do with taxation, so tag them all as possibly insane. There's also things like motoring regulation, so you can imagine that people are thinking about their car tax, or monarchy, that people don't like their taxes paying for the monarchy. Things like that. So it does require some sort of manual cleaning to do. And you want this to be very close to the topic at hand. So property, again, is not salient. Benefits is, I guess, closer than property or monarchy, maybe to taxation, but it's definitely not salient enough. And indeed, in our data set, it's actually its own class. So you ought to be very strict with these, and especially sort of you have those information gain figures, so you can threshold on them. I used a value of sort of 3.5. Just empirically, that seemed to work well. So that's our semi-supervised LDA approach. It's great. We can control the topics that it outputs. As I mentioned before with the driving and speeding and stuff. But even if we see topics, we can still get junk topics out. So we can get an incoherent list of words like we saw right at the beginning with unsupervised LDA. So that's things like national service and tail docking, where actually there's not so many keywords that talk about those particular issues. And sort of in those cases, the model just isn't able to pick out anything. It's looking for more than one sort of phrase. So it doesn't work. So that's where the rule-based approach comes in. So if we have these examples, I think that tail docking should be banned, or we should bring back national service. If we see tail docking or national service in a response, we can be pretty confident that that response is actually about that topic. Tail docking and national service don't come up in conversation very much. So sort of on that sort of very pragmatic view and backed up by some of the data, which I'll come to in a bit, we're fairly confident in this approach. So that's looking for keywords in the just the idea and the why section. So we can do that. We can also use these user-generated tags. So if you remember that each of the topics, the community generates a bunch of tags for them. And these tags are actually a good source of data, of supervision. So things like trade union for things to do with employment, that's very salient as a feature. It's very discriminatory for employment. That's not always the case. People were very tag happy with human rights. So the legal drinking age being 18 and the challenge 25 policy where you have to have ID unless it looks like that you're over 25, that's not really to do with your human rights. So that's an erroneous tag. So we can actually use that same approach before in the information game to look at which tags and which sort of phrases in the topics are very salient, and in the same way as before, we have to sort of manually go through it. And actually, like in the human rights case, the information game for the human rights category, our human rights category, was very low compared to some other topics. And that motivates us why we're doing this research. You know, these tags do exist and they're useful, but they're not sufficiently precise for the kind of analysis that social scientists might want to do. And it's worth noting that I use separate word lists for this. So yeah, between tags and phrases in the idea and why section. We've got a couple of sort of desired properties for this rule-based system. We want it to be high precision. So that's kind of what I was saying before. If we have, if we classify everything that has tail docking in it as tail docking as our topic, we don't want a bunch of false positives. So things like, you know, alcohol, for example, that's mentioned in passing a lot. So if we tagged every response that had alcohol in it as to do with alcohol, that would be wrong. So we'd have a lot of false positives, so we'd have a low precision. We also don't really mind about having low recall here. We're looking for a very precise tagger. If there's false negatives, it's kind of fine. In a lot of cases, we are backed up by the topic model. So in these two cases, tail docking and national service were not. So actually, high recall there matters a lot. But in other cases, you know, the topic model is there to back us up. This is just to give us a little bit of a boost. Why don't we just, yeah, so I've mentioned this. Here's an example of where, you know, speeding tickets, education, and alcohol are mentioned in something to do with maybe policing or something. So the results. We can see there, so for the keyword classifier, we've got very low precision and very low recall across all of the topics. But actually, we only, out of the 50 topics, we only had keywords for 7. And if we restrict our analysis to just those 7 topics in our labeled data, it recalls all of them. The precision here is kind of meaningless because that's sort of the obvious reasons. All of the examples are of classes that we know. So the tag classifier, that has quite high precision as well. That's across the majority of the topics. There's a few topics where the tags, there was nothing in the tags that sort of picked them out. And we have sort of average recall. And if we use both, then we get a slight hit on the precision compared to the keyword sort of topic subset only. But we're covering more examples here, so it's kind of fine. We can obviously also combine this with our seeded LDA approach. So the seeded LDA approach doesn't perform very well by itself. That second row is repeated from the previous slide. And together we can see that we get decent precision, average recall, and F1. It performs very similarly to our baseline. So the baseline is a calibrated SVM. It's just an SVM over TF-IDF features. So those TF-IDF features, you can imagine, is for each document, you have a list of features per word. So TF-IDF is high if a word is mentioned frequently in a document compared with its overall frequency. So speeding, if speeding is mentioned in a document like a lot compared to how much it is on average mentioned, the response is probably about speeding. But things like I, and, or, but, those have very low TF-IDF values because they're just used everywhere. So actually, you can imagine that this approach is actually, this baseline approach is very similar in its ways to the seeded LDA approach. It works on kind of picking out anomalous words which are highly indicative of a topic. And it just does that in a kind of different way to seeded LDA. There's a couple of reasons why I'm advocating for the seeded LDA and rule-based approach. So in practice, it gives better results where a response has multiple classes. So calibrated SVMs, or SVMs in general, seem to only sort of classify, in my experience, just the primary topic or just one of the topics, whereas CDLDA worked better when there were two or three topics mentioned. I also did some error analysis. So CDLDA's, that third row's errors were a little bit more sensible. So in cases where, if the response was about government, it might have tagged it as government spending. Or if it was about sentencing, it might have talked about criminal law or police powers or something. So even if it got it wrong, it was kind of close. And that was less of the case with the SVM approach. It's also quite nice because we can sort of have some fine-grained control over this in a way that we can't with the SVM. So if we want to see what happens if we just remove one of the words as a feature, we can do that, and it's very quick to rerun the model. We can also add new topics if we want to. So if sort of just by looking at the data, there's a topic that hasn't been coded for in the initial 800, but actually we decide we'd like to, we don't have to code up a bunch of examples. We can just look for some salient words. We can't use the approach that I talked about with information gain, but we can just do it by hand, and it's very easy to introduce new topics. So that's topic modeling. That helps us tag all of those news articles automatically without having to do it by hand, and also helps us sort of pick out what are the main topics that people are talking about, and then we can just compare that with what the legislation actually is about. Sophistication, on the other hand, is going to help us think about how the public view the law. So if they're making arguments that are very sophisticated that are based on the law, that helps us sort of answer the question about how they view the law. But if a lot of the responses don't, then that also tells us something. So what I'm presenting here is preliminary work. I don't have any results. It's sort of ongoing, but I'd like to just sort of touch on this. It's a more difficult task. So with topic modeling, you can kind of say, like, look, we've got all of these words. If you're talking about speeding, you're talking about, you're not talking about anything else. You're talking about speeding. But what is sophistication in a response? That's an open question. So there are some features that we can sort of come up with intuitively here. So if they refer to any laws, then it might be a more sophisticated approach if they're making arguments by being like, look at section 3C of the regulations for London. I think it's excessive. But if you just say, fines should be increased, that's less of a sort of built-up argument. And if you can remember at the beginning, we talked about how those 800 responses were coded for whether the response includes a law or not. And it's very easy to extend that by scraping all of the UK law, which is all online, and coming up with some quite complicated regexes to pick up all kinds of variations for how they might be mentioned without the year, without some of the bracketed regulations for London brackets environment or something. It's rare, I think, that people refer to the full text of the law. But we can use that as a feature, and we can use techniques from another field of NLP called argument mining to look at any assertions to pick out, this span of text is an assertion, and then look for other spans of text to say, like, this is where the assertion is backed up with facts. This is a very difficult sort of task in itself, and it's out of scope for this work. But there's some off-the-shelf software that we can use to pull out any arguments that are made. We can also use black box models, so we can just train this end-to-end using a neural network. So there's one that's very popular in the natural language processing community at the moment called BERT, which is just a large pre-trained language model that you can just train in a normal supervised way using our collection of 800 documents with the associated sophistication scores to see where we get what we get. At the moment, accuracy is around 60%, but it's early days, and sort of one interesting approach for this might be, instead of looking at sophistication as a sort of categorical class, it's not very sophisticated, it's kind of not sophisticated, it's medium sophisticated, or it's high sophistication. Maybe we can talk about sophistication on a continuous scale from 0 to 1, and that might make the task a little bit easier. Yeah, so some key takeaways. We can effectively replace manual annotation with semi-supervised topic modeling. And it's not a waste to have previously annotated data. If we're going to use this approach, we can use that annotated data to speed up the semi-supervised topic modeling. And this also opens a lot of areas, new areas for social science research. So it wouldn't be possible to look at analyze sort of news data in comparison to what we're looking at, these survey responses without some NLP techniques. Because while the newspapers have tagged up their own sort of articles themselves, the tags, it's a different tag schema. Some of the tags are very high level. You know, it might just be that you're talking about sports or driving or something, rather than the sort of more fine-grained things we're talking about. We're interested in here for our analysis. So employing NLP techniques sort of allows for this. That's me. Thanks for listening. And I'm happy to answer any questions.
All right. Thank you for your talk. It was very interesting. So if anyone has a question, please type it into the YouTube chat box or in Slido. I have one question first. You showed that in the NLP bit of the analysis, there are some differences in how people express their opinion. I mean, one could be very substantiated with facts, with proper reasoning. The other could be just like an opinion piece. Do you have any sort of analysis of how good of an argument they make, or how do you evaluate how good an argument they're making?
So this is difficult and sort of out of scope. I think it's you can look at maybe, you know, if you can look at the ratio of arguments made to sort of backing statements made. So if they make a lot of arguments, make a lot of assertions without backing it up in any way, you can imagine that that's a less sophisticated response compared with if they had made a bunch of arguments but also backed up each of them. So you can use that, but this is an entire sort of area of NLP by itself, which I think is still sort of very up and coming, and there's a lot of work to do in it. You know, as I say, we're just using sort of, there's off-the-shelf APIs that are all open source and stuff, which is really helpful and sort of I think speaks to, you know, if you stick everything open source, it benefits everyone. But yeah, as I say, so just using that off-the-shelf software.
Okay, and you touched a bit on that, but you said that there are some users that kind of respond in a negative way to, let's say, one line of laws that they don't like, or even everything. Do you think that's common in this corpus? I mean, to have some sort of adversarial actors that are just hating everything, or?
So I don't have data to back this up, but having sort of spent quite a lot of time with the data set, I think no. I think if people mention the law, they tend to have a specific problem with that. Although that said, there are a couple of bits of legislation, especially surrounding human rights, that a lot of people mention by name, but make broad arguments about, which don't necessarily stem from, they stem from like the public perception of the legislation, including sort of how the legislation is being portrayed in the news, rather than having looked at it. But aside from those particular bits of legislation, if someone mentions, you know, some other sort of more specific legislation, then they tend to have a sort of argument about that. But that's, you know, this is something that might be touched on in the later analysis. This is just my experience from looking at the data.
Okay, thank you. Then we don't have any questions at the moment, but I'll share the link to the meeting room that we are in. So if anyone wants to have a further discussion on Guy's or Greta's talk, they can just join in, or we can discuss really anything that is related to, that could be relevant to PyData. So I'm right now sharing the meeting room in the chat. So yeah, do join. And I'd like to thank Greta and Guy again for presenting at our venue. You had very interesting talks. I was very kind of exciting for both of your talks to kind of hear different perspectives, both on R and some applications of NLP that I wasn't very familiar with. So yes, thank you.
You're welcome. We'll come again.
Okay, I'll remember that. I'll ask you again for the to join. So yeah, for the time being, if also you want to discuss something between yourself while the rest of the group joins, you can do that.
So, Greta, can you remind me from your talk, were you sort of used to be a Python kind of person and then switched over to R?
No, actually, I started off with R and then I had to switch to Python for designing experiments. So basically the presentation of the experiments to students, but then I still use R for the analysis.
Mm-hmm.
I tried once to use Python and I went the good way. I went with pandas, which is supposed to be very similar to tidyverse, but my brain broke.
Yeah, pandas is difficult. I think I struggle with it.
I definitely agree with that. I tried converting some of my code that I know that works in R, and I said, I'm going to try and make this in Python. And it took me probably 3 hours to convert a third of my data wrangling code, which should be straightforward because I know exactly what I'm doing. And then I give up at the end.
Yeah, I mean, I think with this analysis, like I talked about today, like I just did that based on parsing a CSV and then working with lists of lists. Mm-hmm. Just 'cause at the time it seemed much easier than sort of delving in with pandas.
Yeah.
Seems like it's worth just sitting down for a day. Maybe if they could do a course like the 3-day course or something that you mentioned for pandas.
Yeah, that would be really good. Maybe if they, although I gotta say that I just found it difficult to kind of get in the mentality of it, even though I think some of the functions are even called the same, if I'm not wrong, and it still makes it extremely difficult to switch from R to Python, specifically for the data analysis. But then when I have to do actual, development with it, in terms of the experiments that we do, it's very straightforward.
Okay.
As long as you're not using pandas, very straightforward is what I've learned.
Is another thing I think that is just like Matplotlib's API. I still have to Google every time.
Yeah, that's a mess. I'm not sure how can anyone be familiar with Matplotlib. I mean,
someone needs to.
That's really good to hear. That's really good to hear, because I think I was at one of the teachings that you and Yasin and Peppa did. They were talking about how great Matplotlib is, and I'm sitting there thinking, I don't understand how is this great. It is not.
I'm sure I didn't say that.
Yeah, me neither. That was Peppa.
We can blame her, she's not here.
Yeah.
And now
So Peppa was working with us, with me and Yasin before. Now she's doing her PhD in the University of Copenhagen with Isabel Augustin, I believe.
Ah, yeah.
Yeah, so after she left, me and Yasin are blaming everything that's wrong in our team on her. So that's kind of our...
Yeah, and now we are blaming you because you also left, so it's all right.
Yeah, that's fine. I know that Yasin has some strong opinions on pandas and using pandas in production environment.
Positive or negative opinions?
Well, at first they were negative, but now since we got some new people in the team, all of them enjoy pandas really, really much, and I have to learn it because I need to, understand their code. So I now have mixed feelings towards pandas. at first I Google everything, and I think that it will be like Matplotlib. Like you said, you just keep Googling stuff every time you use it. I think I'll be the same with pandas.
Yeah. I think
I just want to say that there is this correlation I mentioned it the last time. Georgi came and spoke at PyData, and then he got accepted at Cambridge. So, I mean, good things happen to people that come and talk to PyData Sofia.
Okay. Oh, I'm at the end of my PhD. I'll wait to see what happens. If nothing good happens, I'll blame you.
You probably finish your PhD on time, which I believe is sort of a miracle for a person following their PhD. So I hope that happens to you.
Not gonna have a comment here, Yaska.
Yeah, I'm also following a PhD for like 6 years already, So
Yeah,
I think
you're doing
it's
great.
just us. Maybe the other people are shy. I don't know. There are still some people watching, which is
Yeah, seems
cool.
so. Yeah, there are people watching the discussion, but are not joining for the time being. So yeah, if anyone is interested to continue this discussion, to join.
Yeah, we did a meeting yesterday with, I believe, around 70 people in Google Meet, and there wasn't any luck. So I think Meet can handle a lot of people. We can try doing this entirely in Meet the next time, so people will just be automatically joined, and they don't have to rejoin. So maybe that would work. And also, if I'm sorry, I missed the introduction. Did you say that we are looking for speakers?
Oh yeah, I think I mentioned it. But yes, we're looking for more speakers. So if anyone is interested in talking,
I might be able to find you a person or two or more.
That's great. Yeah.
Great.
We'll take all of them.
Take all of them. Okay, I'll let them know.
Yes,
Depends on what you want them to present. I think I'll be able to find you a person to present a very cool Shiny app that will talk you through everything. So maybe I'll get to convert more people. I don't know.
Yeah, I think we may found a chapter of is there R data or something? We have PyData. Maybe we can find R data.
There isn't R data, but there are quite a bit of R related meetup groups. I think there's definitely one in there's one in Glasgow and there's one in Edinburgh for sure. And I think that they did move online, but I haven't attended any of them that are online, only the in-person one. I need to be able to see people, so this makes it very strange.
Yeah, I can imagine you talking, in an empty room with just, a monitor without any audience. It's kind of creepy, I guess.
Yeah. Well, the good thing is I know that my flatmate is in the other room, and he's talking to a computer and to a room of no people inside. So at least we're in a parallel talking together.
Yeah.
Yeah, nowadays everyone is talking to their computer in an empty room. I mean, it's not that usual.
I was going to say, it's more usual to talk to your computer than to actually speak to someone in person, like at least for me at this point, other than maybe family or flatmates.
Hi, folks. I just want to say hi. I've been, I was on a YouTube channel listening to the discussion, and I said, okay, it's a shame. Let's join. I also have to confirm what Guy just said. I recently joined a new team. I've been working with them for a couple of weeks, but when we met face to face, it was a really weird feeling. Okay, you have a real body, and it was almost kind of unnatural, and that's a little bit scary. Meeting in person shouldn't be unnatural.
Yeah, there's always this luck when it's online. I mean, I think that the main reason is the luck, because when you are in person, a lot of people can talk simultaneously, and it's kind of working. But when it's online, it's kind of weird. there was this app they introduced recently, online village or something, social village or something like that, where you can it simulates a room full of people, and you have your little avatar moving on a map, and if you are close to other people, you start hearing them, and if you are going further away from them, you start hearing them from a distance. And in this way they were trying to simulate a conference with the hallway where people are just doing their coffee break, so you can just walk around and start hearing people. But I haven't tried it at the conference, and then I tried it by myself, so I wasn't really hearing any other people, so I don't know if it's working okay. But it was a nice idea, that you hear people from a distance dependent on where you are on a virtual map.
I think we need half a year more of COVID quarantine, and people will come up with more of this.
Yeah, probably. Greta, you were saying something?
Oh yeah, I was saying that probably at that time when you were able to actually see real people, it didn't sound that exciting. Whereas now it would make a lot more sense. Although potentially it doesn't make much sense in Bulgaria.
Yeah,
You're
here,
only 3 people there now.
here you can do whatever you like currently. I mean, there's almost no restrictions. I mean, there is a restriction to go to discos, but we never did that anyway. So
I think they lifted that restriction too.
oh,
Oh.
Which is not a great idea, but
Well, they can see what happened in Seoul in South Korea, where they opened discos and like clubs, and a week after they had a massive spike in cases in that region, so they had to close them down again.
That was just one person
Enjoy
as
your
well, right?
little freedom.
sorry?
I think it was just one person, wasn't it? That like had it and sort of went to 5 different places and gave it to everyone.
Yeah. To be fair, it only takes one person.
Yeah.
Yeah, you just need one person on this bar hopping, or how was it called, where you just go around bars and
Yeah, a subcrawl, as it's called in Glasgow or in the UK.
yeah, I think that we should get someone to to do some nice visualizations of the spread of COVID. I think there are already some cool analysis on population and stuff. Maybe we should do that.
There is a research group collecting at the moment super spreading events. So events that really led to a kind of a large outbreak, and they're trying to analyze it. As at the moment we're seeing really a subset, and we're hearing about a subset, and it kind of skews the public opinion. Like we've heard in many countries, like singing and attending choir rehearsals or concerts, and it was kind of announced to be a super spreading event, but that's not the only one. But the media kind of focused on that one, and they're trying to really collect a large library of events all over the world that led to outbreaks, and it's really interesting. And it has a psychology element to that as well. Like there is one case in Israel, I think, where the father of a bride had the coronavirus, and it was his daughter's wedding, so he's not going to miss it. And he's greeting everybody at the wedding, and he's kissing a lot of people, and it's a really bad super spreading event. When it's just an occasion that people don't want to miss, or there is a public pressure to not miss, and then you know that you're not feeling well, you're still attending, and really bad things happen after that. So it's actually a good venue for data science work after that. Would be
Leave it to a pandemic to give a lot of data to people to work with.
Yeah.
Yeah. By the way, there's a question for Guy regarding the talk. So the question is regarding the seeded LDA. Is there a library, and is guided LDA another name for seeded LDA?
Yes, sorry, I should have mentioned that guided LDA library implements the seeded LDA paper. So that's actually what I'm using.
Okay.
Yeah. There's a few other topic models as well, but I tried CoreX, or CoreX, correlation explanation, but it didn't work very well. But that was another one that had a library. Maybe it works for different data.
Okay. And there is a question that is towards me, but I'm going to say it again. So, would there be access to the stream recording after the event? So, yes, there would be. It will be uploaded in the same channel shortly, and probably tomorrow or in a few weeks, I will process the talk separately, so they will be uploaded too.
Isn't the link valid after we end it? I mean, the live session, isn't the link the same after that? Can't you just watch it?
I'm not sure how exactly does YouTube work, because when the stream ends, it takes about probably an hour for YouTube to process it, and then they upload it automatically as a video to the channel. So I'm not sure whether the URL is the same, but there is some short period of time after the stream has ended and there is nothing available from this event, but then they upload it afterwards.
Yeah. I have another question for you. Are we going to do monthly meetups in the summer, in July and August? Usually there aren't many people in the summer because everybody's on vacation. But if they're on vacation, they can still be online. So I don't know.
I mean, yeah, we can do this. It's fine with me. We should. I suggest we can maybe make a poll or something to just ask how many people are around that would like to visit this, if it's online or if it's in person or whatever. Obviously, I think that maybe online is a better idea for the time being. I'm not super keen on making the event in person for the time being. But yeah, we can do this during the summer. We didn't do this. We didn't do this last year, but we can try.
Yeah, okay. We just need, lecturers. We need to find some speakers. So if to the 12 people that are still watching now, if any of you is interested, you know where to find us.
You'll be there.
Maybe people won't go on holiday this summer. I don't know where I'd go if I was going to go on holiday. I think my holiday is maybe a different room in the house.
Yeah, there was this joke, I'm going to spend the summer holiday probably in the living room, because in the kitchen it will be too expensive.
There we go.
So yeah. Yeah, here in Bulgaria,
couch to a different chair next to the window, so you can pretend you're in the beach.
Yeah.
Maybe you could even rearrange the room if it maybe feels like you've gone somewhere else.
Yeah, I did that in my first month. I rearranged our whole living room.
They just opened the borders in Bulgaria to Greece, so now you can go at the seaside in Greece without 2 weeks quarantine. And for the first 2 days, a lot of people, there were like lines, huge lines with some cars on the borders, people going there. So if that continues to be the case, a lot of people will just be in Greece in that time in the summer.
Yeah, they shared that 20,000 people left Bulgaria on the first day of after they opened the borders. I'm not sure.
Were there any left?
I don't know. I suppose.
Yeah, Greece starts being really, really nice in June already, and quite a lot of people had their reservations postponed, and then it was like a tsunami wave just released, and hopefully things will not get any worse than that, so we can enjoy our vacation there. Yeah, folks, I need to drop. I just want to say, Guy, thank you for the guided LDA and all the ideas. I think it was very nice talk, and I have a project coming my way that I'll be most probably using that. We're going to get, it's working with texts about invoice denials in the healthcare industry, and then later the appeal letters to appeal the denials, and we'll need to be able to categorize them. So we were anyway thinking about LDA, but now that I've heard about guided LDA, I have another tool to try, and I've seen the libraries. It's always nice when people make an attempt to make it a scikit-learn friendly and very easy to very easy to try. So yeah, one thing I learned, and it will be tried very soon. And if the results are nice, I can drop you a note in just to confirm.
Yeah.
In an industry project, how things are going.
Oh, that's great to hear. Yeah, no, definitely let me know. I'd be curious.
Right, folks. Thanks.
All right.
Thank you. Thank to Georgi and Yasin for organizing.
Yeah.
And for
Yeah,
you
it was
to-
mostly Georgi this time. I mean, I was just, sitting and watching here.
And folks, I hope we have a YouTube channel soon. And if you don't have time to deal with that, I might volunteer at some point in time. As I think it's good to. I'm trying to collect all the PyData channels in the world, and it's very inconvenient. Well, every community has its own channel, but it's still better than having the videos on Georgi's YouTube. So yeah, I might raise my hand at some point in time to help with that.
Yeah,
Okay.
That would be great.
Cheers. Nice evening to everybody.
Okay,
Yeah.
cheers.
Cheers.
All right.
So I suggest we adjourn the meeting too. There aren't that many people left in the YouTube stream.
Yeah.
And I believe it will be only 4 of us here. So yeah, thank you again to Greta and Guy. Very interesting talks. And yeah, we'll probably ask you at some point after another year or so if you want to make a follow-up talk.
Thank
Will
you.
do. Keep us in mind.
Okay, cool. All right.
Bye.
Thank
Yeah.
you. Bye.
Thanks very much.
Bye-bye.
Cheers.